Alright, in my last video we multiplied polynomials, and now we're actually doing the reverse of that process and we're factoring. And so I'm going to run through these quickly, and I'll also give you access to my videos on the different techniques that we use here. So hopefully you remember how to factor. If you can do all these problems, then you're ready to move on and do chapter 5 as far as factoring is concerned. Alright, so first of all, in this case here, notice there's some common factors. 3 and 12 are factors or divisors of these two terms. This has 2 factors of x, this has 1, so they have an x in common, and the same is true for y. And so our GCF, our greatest common factor for these two terms, is 3xy. And then basically at this point we're doing the distributive property in reverse. Since we have 2 terms here, we're going to have 2 here, and our GCF, 3xy times this first term, should give me what I have here. Notice the only thing I'm missing is x. Then we have a minus. And then 3xy times something gives us this second term, and that's what's going to go here. Well, 3 times 4, notice, or 3 times negative 4 will give us the minus 12. We already have the x and 1 factor of y, so we just need a y here. And so we get x, or 3xy times the quantity x minus 4. Now you can always check this by multiplying here. That should be this term. So we're good there. And multiply this times that term there, and you do get this term here. The other thing to watch for is there should be no common factors in these two terms. So we're good there. Now, I want to go back to what I talked about previously. If you had like x minus 5 times x plus 5, and you FOILed this out, you'd get x squared plus 5x minus 5x minus 25, and notice these guys are opposites, and you get a binomial x squared minus 25. Normally you end up with a trinomial when you FOIL, or when you multiply 2 binomials. In the case where you have the same terms and just opposite signs here, you're going to have this situation where you get 2 terms, and we call this a difference of squares. Notice this is x squared, and this is 5 squared. Now it turns out that it's quite easy to factor these, or to go from an answer like this to one here. So I just asked myself, what times itself gives me x squared? That would be x and x. What times itself gives you 25? That would be 5 and 5. One of them will be a minus and one of them will be a plus. So when we factor here, we're expecting to get 2 binomials. And we know something times itself needs to give us x squared, that's x. And something times itself is 49, that would be 7. 1 minus and 1 plus. Doesn't matter which one you make positive or negative. Alright, so if you factor this one here, you're going to get x minus y times x plus y. And again, it doesn't matter which of these goes first. Now this is a very similar problem. You have the same exact pattern, except what times itself is x to the 4th? That would be x squared. And what times itself is y to the 4th? That would be y squared. 1 minus and 1 plus. Now if you stopped here, you would actually be partially correct, but there's something more we can do here. Notice we have another difference of squares. We also have a sum of squares, which we haven't discussed, but it's something that you cannot factor, at least not with real numbers. So this ends up being x minus y times x plus y. I just factored this difference of squares, times x squared plus y squared. Alright, let's move on. So you should be able to factor a trinomial. The technique that I teach is called the AC method. But this one is actually quite easy. We know that from experience that these two terms should multiply to what we have here. So x and x seem like a pretty good choice there. And we also know that these two numbers need to multiply to 1. Well, that's pretty easy. It's got to be 1 and 1. And then we need this inner product and this outer product to add up to 2x. Well, all we need to do here is put plus signs. We'll have a 1x and a 1x, and that gives us the 2x. And so this is x plus 1 quantity squared. So you should be able to do this one in a very similar way. So here we know x squared times x squared is going to give us the x to the 4th. 1 times 1 is going to give us that 1. And we need 2x squared. Well, notice we have a 1x squared here and a 1x squared there. Two of those, or 1x squared plus 1x squared, gives you 2x squared. And so this is x squared plus 1 quantity squared. Now, if you need at some point to factor other trinomials, which you may do in Chapter 6, you may want to watch my video on factoring using the AC method. Or when we get to Chapter 6, I will do a problem or two there. All right, let's look at number 7. This is what we call a sum of cubes. Now, there's actually a formula for this. This is equal to a squared minus ab plus b squared. Whoops, I said that wrong. I just got my order backwards here. What I'm missing is I should have, what you get with these when you factor is a binomial times the trinomial, and I was giving you the trinomial, which is a squared minus ab plus b squared. Now, so in this case, instead of a, we're working with x, so this becomes x. Actually, what I want to do right here is just point out that you can memorize this formula, but I think it's better to know a pattern. There's a nice pattern here. Notice that this number cubed gives me that, and this number cubed gives me that, and our signs are the same. So if you had this, it's pretty easy to get this. In our case, we would have x plus y. So it's just, notice x cubed gives me this, y cubed gives me that. I have the same signs. All right, let's go from there. Now look at what we have here. If you square this a, in fact, what I have here will generate this. If you square this a, you get the a squared. If you square this b, you get the b squared. The hardest part is the middle term. What's the pattern here? Well, if you multiply these two numbers, you get ab. Change the sign, that ends up being your middle term. So you can memorize the formula, however, it's easier to just think of it in terms of a pattern. So here I'm going to square my x, that goes here. I'm going to square my y, that goes here. I'm going to multiply x and y, that's xy. The opposite of a positive xy is a minus xy. Notice that positive, or that y squared is always going to be positive at the end because you're squaring this number. All right, and so that is our answer there. And that's it for this video.